Okay, so welcome back to my lair. This is my latest setup here with this new and improved Mott style electromagnet. They're pretty much identical, facing each other here. This is my Tesla meter probe here, and this is my power conditioner or power modulator, whatever you want to call it, to power this electromagnet. So this plugs into the wall, the outlet here, gets rectified, and then charges up these capacitors to make a pretty smooth DC for this magnet here. So what I have is a bunch of light bulbs I've hooked together in parallel, which will limit the amount of current. It should be about 400 watts worth of power that's able to go through into this. So it's going to charge these capacitors continually. And got this little chopper. It's just a relay, but it's going to act as a chopper to control the sort of like pulse width modulation to control the amount of line current coming in here. So anyway, I'm going to fire it up and keep an eye on this meter here. My goal is to get it to about 3,300 Gauss of magnetic field strength here. And this is a pretty uniform, quite uniform in here. So while it's on the camera here, this is a 555 timer circuit that's set to do 6 millisecond pulses on a 6 millisecond 50% duty cycle, so on and off. And this will be the power supply for the gun diode here. That's just directed towards the center to try to hit the sample, which I'm going to suspend here. And this is an example of a sample. This is aluminum oxide or hydroxide powder in here, which I have tested with no results yet. The other sample is right here, another identical tube with this is aluminum foil, and this is just some aluminum wire here I put in. These are tiny little pieces of aluminum foil, and it's supposed to be, well, I read somewhere online, it was supposed to be 99% pure aluminum. So the goal is 99.999 or better percent. But we'll see if that does anything. The big difference with this experiment is the making a uniform magnetic field across here, whereas in my previous experiments it wasn't a uniform field. So on the count of 3 here, I'm going to fire up this magnet here. 1, 2, 3. So we're up to, looks like 100 and, no, it's not 100, it's like 1130 Gauss. Okay, something's not quite right here. Hold on a sec. Okay, here we go, electromagnet test. I'm going to charge up the capacitor bank here. Setting up the relay switch. So watch this here. So 3,500 Gauss. 34 and 80. It's getting closer to where we need to be. 34. Oh, and my probe falls over. Okay. That'll be the end of this test. Oh, there we go. 3380, that's pretty close to where we need to be. Still a bit too much fluctuation though. I'll have to iron that out. And here's another trial. Five, 34. It's pretty good there. Just a little less. There, 3,360 Gauss. 3,300. It's perfect right there. 4.4 hertz. Okay. And the coils start to heat up here, and then this drops a little more, so I can only run it for about a minute. Alright. Okay, so this is my setup before I put the sample in. Got the probe here, and the gun diode is there. It's going to shoot right into that cavity, and hopefully that'll do what it's supposed to do. Alright, so the sample is going to be suspended right here, right about here. It's going to be suspended, and then, yeah, so this is all set up and ready to go. Okay, so here is the setup. It was very finicky to get this set up, but I don't know if you can see down there, but that tube is being suspended right down there in the middle. So anyway, touch this thing here gently. It should move the scale, and we'll just see what happens here. Okay, so Tesla meter on, microwaves on, capacitors charge, and power regulator on. Of course, a lamp dimmer circuit or something like that would be a lot better than this, but this is what I just put together for now. Okay, so I'll put the camera here, so just you can see the magnetic field. I'm going to turn it on now. And I got a 0.03 on the scale. 0.03 grams, then it went to 0. I'm going to try and get it closer. Well, it's about where it needs to be. Yeah, it's still reading 0 here. So I got to get the resonant frequency. I don't know exactly what it is. So it's at 3,170 Gauss minus 4.04. But I don't know. Minus 0.04. Back to 0. 0.3. It's fluctuating a little bit. I don't know. 3,000 Gauss. Need to be a little higher. 0.06. 0.08. Oh, turned off. I need to turn it off. My coils are going to heat up here. So everything is off right now. But this is kind of what the scale is doing. Started out at 0. Just kind of does that sort of thing. And there is a little bit of, just the tiniest amount of, I can sense a little bit of warm air coming up here. So I think maybe, I haven't ruled this out, but oops, there's a little bit of, as the coils heat up, it slightly warms the air and then causes a little bit of updraft. So that's one source of possible error here. Other than that, I can't explain why the scale is changing, other than it's gravity control. So I've been watching this scale for some time here, and it's still doing this. Still fluctuating. Oh, it's finally, it goes a little, if that's indicative of anything. You know, it might be, if this is a shifting in mass, it could be something like a quantum effect where it just kind of goes in stages as the atoms, as the nuclei relax. There's these fluctuations in mass. I don't know. Might be possible. Oops. Okay, so I put this tape here like this just to try to slow down any convective air currents that might be trying to rise here. And it should. However, I'm still getting these goofy readings on here. And I even grounded the plate here. Right here. Connected that to ground. Yeah, I don't know. Maybe I need new batteries in the scale. It's not telling me that though. There's 0. Okay, I'm going to do one more test with the same sample. Okay, here goes. Microwave on. Scale at 0. 3,330 Gauss. $3,200. Scale saying 0 now. Still 0. I turn the microwaves off. 0. On. 0. Alright, looks like it's heating up again. Shut it off. Scale says 0.11 grams, so 0.17. 1.4, 1.2, 0.05. There's still a little bit of a magnetic field there, and the microwaves are still on, so 470 Gauss. I don't know, maybe I hit a harmonic or something, who knows. Okay, I'm going to shut it off.